So hello everyone. At Lenovo we work with ARM hardware and especially the HPC servers, and so we work with bare metal servers. So we need to have a set of tools and an infrastructure that allows us to provision and install the whole OpenHPC stack, run benchmarks, and in general analyze the performance of ARM servers and see if we do a CI and see the performance gain and try to get a clear picture of what is happening. So we do this with multiple tools. So we got a provisioner, which is Mr. Provisioner. We use Jenkins as a job dispatcher. The HPC stack we use is OpenHPC. And this whole thing is installed and coordinated with Ansible. So how do we set up the lab? So we have, to host the services and the tools, we have multiple KVMs. We use libvirt. And so the provisioner, the Jenkins, and the other services that are regrouped in the file server are all installed on those virtual machines. These are installed by an Ansible recipe that is more or less all contained in the HPC lab setup. You see the link just there. So how do we, for the network setup of this administration part of the lab, we use static IPs. We have two different networks. Because we use bare metal servers, we have the BMC network, which is used to administer all those servers, reboot them, and in general access the IPAMI SOL. And we have the other main network, the provisioning one. Of course, on both of those networks we run DHCP. This DHCP is hooked up to the Mr. Provisioner so that they talk to each other. So as I said, all of this is installed via Ansible. And we use as well SFTP to store all the results of the test we do. And we, of course, need to be able to store them securely and provide a private storage space, because our members, which are private members, so Huawei, Qualcomm, KVM, whatever, they do not want the public or anyone to be able to compare easily their servers, so a Huawei server to a Qualcomm server. So we need to provide them with a secure and private storage space. And we use as well a package cacher, because we need stability in the lab and we need to have a fixed and set environment to do all our tests. There is a private Git repository. The whole thing is not public because there is some configuration in the Jenkins, since it's all hooked up to the LDAP, that is, of course, we can't share. So one of the big services, big tools we use is Mr. Provisioner to do all the provisioning of the bare metal servers. So, and this includes talking to the BMC to reboot it, to reboot the server, and PXE boot it, of course. And this, I'll show some screenshots after that, but of course this, we also have console access, so we can monitor serial output from the machines as they are being provisioned. The Mr. Provisioner is built in Python with the Node.js front end and Postgres SQL back end. It talks to the Kia ISC's Kia DHCP, and which features events and easily dynamic networks, subnets. And all of this is done per MAC address. We provision them with first the bootloader. The bootloader chain loads the PXE installed from the distribution, whether it be CentOS, OpenSUSE, or Debian. And Kia also features, also hooks up to Mr. Provisioner, providing machine discovery, so that is easily accessible, and all of this is automated. The Jenkins, we have a couple of jobs. The management of the Jenkins is all done via Ansible. Everything is in a GitHub repository, meaning everything is versioned and very easily manageable. And finally, the file server, as I've already mentioned, needs a secure and private storage space. And we've got a package cacher and some storage for the tool chains that we use for the benchmarks. Again, because we need a fixed and set environment that doesn't change between runs. Reproducible environment, sorry. So here is Mr. Provisioner. So this is what you would see if you click on one of the machines in the Provisioner. So you have a quick overview of some of the parameters, the architecture, what's its status, the BMC associated with it, and multiple interfaces. We have the BMC interface in it as a quick reference. This is how we do it. This is not necessarily compulsory. You've got a couple of actions on the side. So you can access the console, reset the IPMI console, and of course PXE reboot, and power cycle the machine. As you see above, there is the other services provided by the Provisioner, which is how the images you have, the precedes you use to automate all the installs, the list of BMCs, the Discovery tab, which is the Provisioner talking to Kia to see which machines have been brought up on the network, and the multiple networks and infrastructure architectures that are, we delve into how the Provisioner itself works and the different settings associated with the different machines. So here are the provisioning settings. As you can see, there's a sub-architecture which corresponds to which bootloader you will give the machine on PXE boot. And then the kernel command line, initRD and pre-seed files that we use to provision the machine. There's the users that have access to this machine and can do stuff on this machine. The users have SSH keys associated with them, and these SSH keys are then used in the pre-seed to provision the machine directly with those SSH keys, so that you don't need a root password. There is no password, no users. There's only SSH keys and SSH authentication. And of course, there's the event log. As you can see the DHCP requests and in general the DHCP traffic. So you know if the machine has effectively installed the OS and has correctly rebooted and asked the DHCP for an IP address, meaning it's initialized at least the IP stack. This is the serial console. You can download the log, which is very useful for Bugzilla reports. And then we come up with the Jenkins part. So here are the main jobs that we use in the lab. There's the benchmark job, the OpenHPC install and test suite jobs, and there's the whole provisioning job ecosystem. The provisioning job ecosystem consists of two main entry points, which is the cluster provisioning job and the machine provisioning job. So you can either provision the whole cluster or provision one single machine, which is especially useful for benchmark. So we have the multiple configuration options. Note that this is still in progress. We have the benchmarking job. We support Lulesh, Himeno, and OpenBlast with all the different options and configurations available directly from the job interface. And the OpenHPC jobs, install and test suite, still work in progress, but we have a couple of options. And here is the OpenHPC matrix that we have to test. So all the different dimensions that we need to be able to test in different configurations. And here, especially what is important is the different provisioning options inside the cluster. So how does the master provision the slaves? So this is either done all flat with Ansible or done with Werewolf. At the moment, only Werewolf supports R64. We will work on XCAT support, hopefully. And in conclusion, we have tried to make our lab very modular by developing iteratively and trying to get the best design. We have multiple configurations because we need to test multiple dimensions. This is low maintenance because everything is automated and wonderful, and the SDI is versioned, so we can easily pinpoint problems. And finally, we have multiple options with OpenHPC because we need to test all the different configurations possible in the environment. And we are still working on some of the Werewolf options, but this is something that will come. And that's pretty much it. Thank you very much.